Hey guys, welcome to my channel Medical Pharma Education. In the previous classes, we have discussed about the theory, modes of vibration, sample handling, instrumentation of the dispersive, and Fourier transfer infrared spectroscopy. Fourier transfer infrared spectroscopy I have not discussed, but in today's class, we are going to complete this IR spectroscopy with the completion of the Fourier transfer infrared. Okay, guys. This is a very important topic. In our semester exam, they have asked the instrumentation, or I think so, the diagram. They have asked the diagram and the mechanism involved in the Fourier transfer, and the modes of the vibration. And this Fourier transfer infrared, it's very important for your exam point of view. Mainly focus on these two topics, then go on the other topics. Okay. Firstly, Fourier transfer infrared spectroscopy. Infrared spectrum is an important record which gives sufficient information about the functional groups of a compound. See, here it is very important, which gives the information about the functional groups. Okay, functional group of the compound. Okay, this is the very important, and it has very other important functions. You can see it is divided into near IR region, mid IR region, and far IR region based upon the ranges. Next, uh, FTIR, infrared Fourier transfer, the preferred method of infrared spectroscopy. FTIR is more preferred than the infrared spectroscopy, than the normal IR instrumentation. FTIR is more preferred. Okay, a method of measuring all the infrared frequencies simultaneously rather than individual as with dispersive instruments. See, I have already told in the previous instrumentation, in the double beam instrumentation, we use a thing called as interferometers, where we record all the infrared frequencies simultaneously rather than disperse individual as well as rather than individual as with dispersive instrument. In dispersive instrument, what we do, we select a particular wavelength and record it, then next wavelength. In Fourier transfer infrared, we are recording all the infrared frequencies simultaneously. This is the difference between the dispersive instrument and the FTIR instrument. Okay, we will give, firstly we will in many question papers the awas the why it is important and how it is different. We'll just give the importance of it. Okay, firstly, it is non-destructive technique. Here the sample is not destroyed, it is just analyzed, but in other methods it is destroyed. Okay, it provides a precise measurement method. It is a precise measurement method which requires no external calibration. See, in this method, right, there is no requirement of the external calculations, because directly all the values will be displayed on the readout devices. Okay, it can increase scan speed, collecting a scan every second. See, in the normal dispensive instrument, in the normal dispensive spectroscopy, it takes several minutes, but in FTR it takes few seconds, and it can scan every second. But the dispersive spectrometer scans per minute. Here it scans per second. That's the main difference and the main advantage of the FTIR. Okay. Next, it is mechanically simple with only one moving part. See, in the dispersive spectrometer, the instrumentation is difficult, or construction of the instrumentation is difficult than compared to the FTIR. These are the advantages, and why we select, if the examiner asks why we select FTR than the normal IR instrument, these are the points you have to mention in your answer sheet. Okay, next, what is the difference between these two? Mainly it takes several minutes, I already told you. It takes several seconds or a few seconds. Okay, here that a detector receives only few percentage of the energy of the original light source. See, the main and most advantages is the detector receives only a few percentage of energy of original light source. Here, more moreover, the detector receives up to 50% of the energy of the original light. See, 50% and few percent, it's a huge difference. So that we prefer FTIR than the normal IR spectrometer. Okay, I think so I've understood the difference. Next we'll go with the instrumentation of the FTIR. In the instrumentation, the FTIR and the normal IR spectroscopy, there is no much difference. There is the difference in the monochromators. The monochromators are replaced by interferometers. As I already said, I think so I have mispronounced the word interferometers. Interferometers. Okay. This is the main difference between the normal instrument and the FTIR instrument. Okay, let's continue. The heart of the FTIR is a the heart of the FTIR is a Michelson interferometer. I think so I have pronounced correctly. Michelson's interferometer. See, the main part here is the monochromators, that is interferometers. Michelson, because he is the scientist who discovers the interferometers. See, the monochromator is replaced by an interferometer which divides the radiant beam, then recombines them in order to produce repetitive interference signals measured as a function of optical path difference, as the implies. See, I'll just explain you the sentence which I have written. See, the monochromators are replaced by the interferometers. Okay, these interferometers divides the radiant source, divides the radiant beam or the light source. Okay, into two. I think so. I'll show the diagram. If possible, I will show the diagram. Okay, I'll show the diagram where the uh, light is divided into two. It travels to the fixed mirrors and it travels to the moving mirrors. Okay, I'll show the diagram in I'll edit the diagram here. You can just see. Okay, next. Recombines, and the light is recombined and reflected back in order to produce repetitive interferon signals. Okay, repetitive interferon signals. Okay, measured as a optical path difference, this is the main advantage. Firstly, it divides and recombines. Okay, it divides and recombines the radiant source. The interferometer produces interference signals which contains IR spectral information generated after passing through the sample. After the division, and they are what they'll say, they are resent into the sample, and the results produces signals which after the passing of the sample. I think so I've understood the main topic. Okay, mainly it contains, I'll just explain the instrumentation of the interferometers. Okay, it contains a moving mirrors, fixed mirrors, and a beam splitter. Firstly, mirrors. And in an FTIR are generally made of metals. Here the mirrors are made up of metals. The mirrors are polished on the front surface and may be gold coated to improve the corrosion resistance. Here the mirrors are made up of metals and may be polished in the front surface and be coated with the gold surface to prevent the corrosion resistance. Okay. Next, the beam splitter. Again, by the word only you can just write the instrumentation. Beam splitter, it divides the beam, it splits the beam from the radiation source. It can be constructed of a material such as silica, or GE gallium deposition in a thin coated onto the IR transparent substance. Okay, germanium or silicon, I think the GE germanium or silicon is coated into the highly polished substance by vapor deposition. This is how the beam splitter is made. Okay, next, constructions. Two mirrors are perpendicular to each other. The beam splitter is a semi-reflecting device and is oftenly made by depositing a thin film of already we have discussed germanium into a flat potassium bromide substance. Okay, I think so I've understood the moving mirrors, fixed mirrors, and the beam splitter. Moving mirrors, which are the mirrors that are movable forward and backward. Next, the working. We'll understand the working. Firstly, I'll explain the diagram. See, here the source, interferometer, sample detector. I'll show you the diagram here. Firstly, you can see in the middle IR source is present. It is the IR source. There are various types of IR source we already discussed. From the IR source, the light travels through the beam splitter. See, the beam splitter, it is splitting the IR light, infrared light into two parts, into the fixed mirrors and the moving mirrors. Okay, fixed mirrors and moving mirrors, it is dividing the light. Then it again, the what the mirrors do, mirrors reflect back the light. Again the mirrors will reflect back the light, and through again the light is passed through a sample, then it reaches the detector, and the detector records the values. Draw this representation also, or it is the mechanism how the process is happening. Okay, next we'll go with the advantage and disadvantages of the FTIR. See, the main advantages are it see there are many advantages. I have written 6. You can refer the internet for more advantages. See, firstly, it is a simpler mechanical design. We have already discussed. Powerful data station. As I already said, it is very sensitive for and highly accurate than the other IR spectrum techniques. Universal techniques. It can analyze any samples, and sensitive, fast, and easy. Next, uh, relatively inexpensive and provide rich information. Okay, relatively inexpensive and provide rich information. Next, sensitivity to molecules, anything that contains chemical bond. See, it is very sensitive that the chemical bond also can be analyzed. Okay, next, the disadvantages. Why we have not we can't select the FTIR. See, cannot detect atoms and mono atoms. Okay, or a single atoms entities containing no chemical bond. If the chemical bond is not present, the atoms cannot be detected. Means if the element like chlorine, bromine, single atoms in the mixture cannot be detected. Cannot detect molecules comprised of two identical atoms, symmetric, such as N2 and O2. Already we said, we have discussed the atoms which are similar atoms cannot be detected, and mono atoms cannot be detected, and single atoms also cannot be detected. Example, single atoms like chlorine, iodine, bromine, any single atoms cannot be detected. That's it. It should be like example, it should be like it should have like chemical bonds. You should have the chemical bond. Here the chemical bonds involving in the carbon, hydrogen, carbon, oxygen, and oxygen, hydrogen. So in this way it is can be detected, in this way it can't be detected. This is the main disadvantage of it. Okay, aqueous solutions are very difficult to analyze. Water is a strong IR absorption. So see here, it's a very good point. The water, why we don't use water as solvent, this is the main reason, because water absorbs the IR radiation, and aqueous solutions cannot be used. Okay, complex mixtures, sample gives rise to complex spectrum. Okay, see, in this the sample is analyzed by the spectrum, and a simple atom can also give the spectrum. And here, if the complex mixture, or example, if the sample contain two or three mixtures, then the spectrum is so difficult, like it is so difficult to analyze, right? You can't know where the compound shows the IR spectrum. So these are the disadvantages. I think so I have understood the importance, diagram, and the instrumentation of the FTIR. By this we will complete the IR spectroscopy. I'll just give you the notes. For now I am giving the notes in early on classes. After completion of the syllabus, I'll just give you a link where you can just download the notes. You can just pause the video and you can write the notes. You can just tell me if I'm not going in the direction that you needed. If I'm explaining correctly, just comment me, it will motivate me so much. The mirrors and the beam splitters, next the constructions. Okay, next the working. Mainly here the monochromators are replaced by the interferometers. That's the main difference. I will give the diagram here. These are the advantages. Okay, thank you guys for supporting me. Just a subscribe makes me happy. Thank you. Let's see, continue the next topic in our next classes. Thank you guys. Bye. See you in the next class or in the next video. Bye. Take care.